Hello, this is Hui. Welcome to watch my video C++ programming on Linux. In this short video, it's going to discuss Libevent, an event notification library. As we know, network is very common and popular today, and there are many concepts, technologies are used in networking I/O communication project. Libevent is one of the most used library for network I/O programming. Libevent is an event notification library. The Libevent API provides a mechanism to execute a callback function when specific event occurs on a file descriptor or after timeout has been reached. Furthermore, Libevent also supports callback due to the signals or regular timeout. The internal event mechanism is completely independent from exposed event API, and a simple update of Libevent can provide new functionality without having to redesign the application. As a result, Libevent allows portable application development and provide most scalable event notification mechanism available on operating systems. In short word, Libevent is a library provide faster, portable, synchronous, no blocking event notification network programming mechanism. There's many famous network programming using Libevent. For instance, Google open source web browser using Libevent, and there's many of others. Libevent can be downloaded and installed from apt-get repository on Ubuntu and Debian Linux. Here is our Ubuntu Linux. We're using version 22.04. To download and install, the command will be after installed, the header file will be found under user include event2 directories. This is the old header file, and the library will be found under lib x86-64 Linux GNU, so ls manual. This is the old library. Using apt-get repository to install Libevent, it may not be the latest version, but it will be the Ubuntu Linux or Debian Linux approved version. The latest version can be found under Libevent official website. Here is Libevent official website. The latest version will be libevent.2.1.12. You are able to download this .tar.gz file and following the instructions. The example of this short video is going to write a C++ socket I/O TCP client program using classic block pattern and a socket I/O TCP client program using Libevent. The classical network I/O program pattern for the client, create or allocate a new socket. Second step will be connect request to the server, and after server accept connect request, it will establish connection between client and the server. After that, you can loop to send data to the server. This is a classical network program flow. It's a blocked I/O call pattern. In short word, when program connects the socket for I/O, it does not return until the operation is completed. Blocking I/O is not a bad design. It's simple, easy, and clear pattern, but suppose you need to write a program to handle multiple connections at once, and you don't know which connection will get input first. Blocking I/O model will be very difficult to handle, or at least not able to efficiently handle socket communication. There are few ways to deal with multiple connection situation, for instance, using multi-threading or multi-process. In this short video, it will discuss how to use Libevent notification process in network APIs. Here on our Ubuntu Linux environment, we create two C++ programs, my blog client.cpp, my event client.cpp. My blog client.cpp is a synchronous classical blocked I/O pattern client example. My event client.cpp will be the asynchronous, no blocking event notification TCP client. First, we start with my blog client.cpp. The example usage will take two arguments. Argument 1 will be the URL, which is the IP address. Argument 2 will be the port number. The step will be first get a host name and the port number from the command line. And second will be resolve the IP using the getHost by name function. Third one will be the allocate a new socket. And the next one will be the connect to the remote host. And after establish the connection, it will be able to make a loop, get a message from the console, and send a message to the server using send function, and we receive message from server using receive function. Finish the loop, close socket, which is close the FD. First, get a host name from command line. Host name from argument 1. And port number from the argument 2. We print out the command line and the argument. Next will be the resolve the IP address by host name. Using the function get a host by name. If the pointer h is none, it means resolve the host name got error, so we print out. Return with the errors. Next will be allocate a new socket function socket. Here's the socket function description. Create endpoint for the communications. This function takes 3 parameters. First is the domain, second is the type, third one is the protocol. Domain could be F-Unix, F-Local, F-Internet. Since we are using the IPv4 Internet protocol, so our protocol will be the AF-Internet. Type socket stream provide sequence reliable two-way connection based byte streams. So this is our socket type. Next one is the protocol 0. So we copy this back to our VI editor. Return code, we name it fd equals socket. First one is the AF-Internet. Second one will be socket stream two-way connection 0. If fd less than 0, allocate a new socket failed. We just print out error. Returns with errors. After allocated a new socket, print out. Next will be connect to remote host. Function connect. Function connect will be initiate a connection on a socket. Connection function returns the integer and 3 parameters. Socket FD, structure socket address, and socket address length. We copy this, so we paste here. Return code rc equal connect socket fd socket address. We have to declare using the struct socket address in Here is the socket address, and for the internet domain socket, the structure will be structure socket address in have 3 members: family, port number, and structure in address. So our SIN family will be AF, which is the IPv4 Internet Protocol. The port number will be convert to H2 NS address H. So size of the address length will be if return code not equal 0, which means connection failed. We close. Next, we'll make a loop, get a message from console, send a message to remote, and read back from the remote servers. We make a for loop. Print the input message. We memory set sending buffer and receive buffers. Here we allocate a receive buffer, send buffer, which maximum length we defined 1024. After that, we get a message from console using function getLine. Message length using string send buffer. If no message, we break from loop. Okay. Next will be send message to server. Number written equal send buffer message length. After that will be received from server. Received length equal recv fd socket receive buffer maximum length. So we can print out received message. First is received message length. Second, send message length. And then message received. Receive buffers. Finish the loop, close socket, then we return 0. This is a classical, typical block pattern TCP client. So we save this program. We go to the next program, my event client.cpp. The flow for TCP client using lab event step 1 to 4 is the same as the previous example. We need to get host name, port number, resolve IP address, allocate a new socket, and connect to the remote host. In order to save typing, we go back to the previous example, copy, paste here. So we go back to the previous program. We copy this 28 line. Then we go back to our program 2, my event client.cpp, paste here. Declare socket in IP address. We also need to declare event pointer. Step 5, create event base using event base new functions. Name it base equal If not a get pointer base, it means create a new event failed. We close socket, return -1. If success, print a message, allocate a new socket, and create a new event base. We need to start a loop. In each loop, set socket no blocking using the function. If already set read event, will free allocated event using function event free. Then we can start input a message from console. Member set message buffer. Here we define the max length is 1024. Message buffer max length define a do read, do write count. Now we go back using the get line. Type in message from console. Using strlen function to get the message length. If message length equals 0, we just using continue back to re-input message. After that, we can using send function to send our message to TCP server. First parameter is the socket, which is FD. Second parameter will be the message buffer. Third parameter is the message length. The flag is 0. Set our do read count equal print out. First message length. Second message sent. Now we need to add event. So our read event, new base for socket. The event will be ev read, ev persist, and our callback function do read. And the parameter we pass to this callback function is the pointer of event base. After create a new read event, we need to add event to event loop. And then we dispatch event loop using function. Finish the loop, we need to close socket and free our event base. Then we return the 0. For callback function, do read. This callback function will take 3 parameters. First is socket, FD. Second is short events. And the third parameter is the argument passed to this callback function. First, we decoding the argument, generate the pointer base. And this callback function, we need to set up receiving buffer, set up FD no blocking using the function event make socket no blocking, and the receiving date from the socket using the function receive. And there's 3 function can break event called the event base break, event base loop exit, and the event base loop continue. So in this simple example, we just one time receive the message and break this event. We allocate the memory, receiving buffer, we using the receiving function to receiving the message from the socket. Receiving function take a 4 parameter. First one is the socket, FD. Second parameter is the buffer, receiving the message to. maximum length flag 0 print byte received. Do read count is the number of message we supposed to received. Receiving buffer. Then we call event base loop break read event, and we back to input the message again. And right now we finished our program and we save our program. We compile our program. Now we have compiled our program. Executable is my block client and my event client. To test our program, we using TCP echo server from one of our previous videos example. This TCP echo server is on our Debian Linux. IP address is 1.0.0.124. Our client executable is our Ubuntu server. IP address will be 1.0.0.191. We first start our TCP echo server, port number 1234. We run our block client. First argument is the IP address. Second argument is the port number 1234. Now we type in message from console. Message 1. So after we send this message to echo server, so this is the server received message. The length is 39 and the server reply. So our client received the message. This is Hui test block client message 1. Try again. Message 2. Server received this message. This is Hui next test block client message 2. The byte is 44 and the server reply back. Client received 44 byte and we're supposed to receive 44 byte. Now we quit this client. We try to run our my event client. IP address, port number 1234. Now we input the message. We send the message, server received. This is Hui test event client message 1. Byte is 39 and we send the second message. Server received. This is next Hui test event client message 2. Byte is 44 and server send back do read event received 44 byte. This is next Hui test event client message 2. The advantage of live event is able to set network communication application using no blocking model, so it's feasible to handle multi-connections API and improve programmer efficiency and performance. It's widely be used in many network communication related applications. Hello, this is Hui. Thanks to watch my video. Wish it's helpful and it's going to be great to have your feedback.